Now I want to estimate the demand function, demand for chicken. And suppose I have collected data like this. So Y is the per capita chicken consumption. PC is the price of chicken. PB is the price of beef. YD is the disposable income per capita. R is the interest rate, and I collect data from different years. So this is a time series data. Okay, first step is to set up the empirical models. So I know that demand for chicken will depends on, say, alpha 0 is the unknown parameters that I want to estimate from the data, plus alpha 1 A1 times price of chicken, plus A2 times price of beef. Remember that beef is a substitute of the chicken, so price of beef conceptually can affect demand for chicken. Also, is 3 times incomes. So income conceptually is likely to affect demand for chicken as well. Maybe higher incomes, I'm going to buy more chickens, and I can plus an error. And I do not include real interest rate. Conceptually, it does not affect the consumption of chickens. Okay, that's my empirical models. I want to estimate what A0, A1, A2, A3 are from the data. So now I can regress Y against PC, PB, YD. Okay, let's use this data analysis function, regression here. So input dependent variables here is this Y. And dependent variables X is PC, PB, and YD. And my selection includes labels. I want to output the results, say here. Okay, here's the results. The intercept here is A0, so it's 31.2622. PC is the coefficient of chicken price, so it's A1 is negative. So by low demand we expect chicken price increase. Demand for chicken will decrease, and the coefficient of price of beef is positive, which is A2. Again, that's consistent with our expectation as well, because beef and chicken, they are substitute to each other. An increase in the price of beef, consumers will walk away from beef and substitute towards chicken, buy more chicken instead. The coefficient of income, which is A3, is positive. So, and is statistically significant. So it says that high incomes consumer will buy more chickens. Okay. In estimating this demand for chickens, I'm using observational data, and in particular, these data are time series. There are actually a number of issues that we can have in our estimation here. Potential issues include omitted variable. So there might be some important variables that we do not include, which could be correlated with our right-hand side variable here, like price of chicken, price of chief, and income. In such cases, our estimation will be problematic and there could be autocorrelation here because now we are using time series data. There could be other issues like heteroscedasticity if we are using cross-sectional data. However, I will not talk about these particular issues. I'm going to leave this to an econometric subject. If you have done an econometric subjects, these issues will be discussed in more details there. For our purpose, we only need to be able to conduct the regression, collect data, formulate the empirical models, run the estimation using Excel, and interpret the results. So that's the coefficient estimate. Okay, after the estimations, we want to be two things you want to look at. First is the R squares, adjust R squares. It is between 0 and 1. So it says to what percentage of variation in the data are explained by our regression here. And certainly the higher the better. So here is pretty high, not surprisingly, because we are using time series data. Second point you want to look at this regression output is whether individual coefficients, whether the estimate of A0, A1, A2, A3 are statistically different from 0 or statistically significant. To do so by checking the t-stat. So compare the absolute value of t-stat with 1.96. Rule of thumb is if the absolute value of t-stat is higher than 1.96, we are going to say yes, it is statistically significant at the 5% level. Again, I'm actually assuming you understand hypothesis testings. I will not explain here, and instead you will, if you do econometric subjects, you will know more about this. Okay.